We're told the temperature in an office is controlled by an electronic thermostat. The temperatures vary according to the sinusoidal function y is equal to 19 plus 6 times sine 15 times x minus 11, where y is the temperature in degrees Celsius and x is the time in hours past midnight. The first part of this question is to answer what is the temperature in the office at 9 a.m. So 9 a.m. is 9 hours past midnight. So in our equation, we're going to let x be equal to 9. We would then have that y would be equal to, and since y is the temperature, y is going to be equal to 19 plus 6 times the sine of 15 times 9 minus 11. This is equivalent to 19 plus 6 times the sine of 15 times negative 2, which is negative 30. And I should have mentioned that this is all in degrees as well. So we have 19 plus 6 times the sine of negative 30. Sine of negative 30 is negative 1/2. So we'll have 19 plus 6 times negative 1/2, which is equal to 19 minus 3, which is 16. So therefore, the temperature in the office at 9 a.m. is 16 degrees Celsius. The next part of this question says, what are the maximum and minimum temperatures? So to answer this part of the question, we have to think about what the maximum and minimum value of sine of theta is. So sine of theta has a maximum value of 1 and a minimum value of negative 1. So that means that our function is going to have a maximum of 19 plus 6, which is equal to 25 degrees Celsius. The minimum is going to be 19 minus 6, because we'd have 19 times 6 times sine of it would be 19 plus 6 times negative 1, because the minimum value of sine of any angle is negative 1. So the minimum would be 19 minus 6, which is equal to 13 degrees Celsius. So therefore, the max temperature is 25 degrees Celsius, and the minimum is 13 degrees Celsius. The next question says, at what times during the day do the maximum and minimum temperatures occur? So let's think about our equation here. We've got y is equal to 19 plus 6 times the sine, and let me go back up here for a second, times the sine of 15 x minus 11. Times this 6 times the sine of 15 times x minus 11. Okay. So here we want to figure out at what times do the maximum and minimum temperatures occur. So we know that pardon me. We know that sine of theta has a maximum when theta is equal to 90 degrees. So that means that this function has a maximum when sine of 15 times x minus 11 is equal to 90. So we have 15 times x minus 11. So max, the maximum is going to be when 15 times x minus 11 is equal to 90. If we divide both sides of this equation by 15, we get that x minus 11 is equal to 6. So x is equal to 17. So recall what this function is actually represents. X represents the number of hours past midnight. So x being equal to 17 corresponds to 17 hours past midnight. So that would mean that 17 hours past midnight. Well, that's 5 hours past noon, which is 5 p.m. So we could just subtract 12 from this, and this would give us the time of day when the maximum occurs. So this is 5 p.m. That's when the maximum occurs. So we could say the maximum occurs at, let me erase this. The max occurs at 5 p.m. each day. The next thing we have to figure out is what is the minimum temperature. So to figure out what the minimum temperature is, we have to think about when does sine of theta have a minimum? When is sine of theta? Sine of theta, the minimum is -1, and when is sine of theta -1? Well, sine of theta is a -1 when theta is equal to 270 degrees, but also when theta is equal to -90 as well. So when theta is equal to -90, sine of theta is equal to -1 as well. So because 270 degrees and -90 degrees are coterminal. So we can use theta being equal to 270 degrees or theta being equal to 90 degrees as well. And then we could just figure out what times these correspond to. So let's say, let's use theta being, and we can say, and theta is equal to -90 degrees. So let's go ahead and we'll figure out when 15 times x minus 11 is equal to -90 degrees. If we solve this equation, we get that x minus 11 is equal to -6, and so x is equal to -6 plus 11, which is equal to 5. So this corresponds to 5 hours past midnight, which is 5 a.m. So therefore, the minimum occurs, the minimum temperature, I guess we should write the minimum temperature. Occurs at, occurs at 5 a.m. And if you think about it, this makes sense because the minimum and the maximum of a sinusoidal function. So if we actually sketched out a sinusoidal function, or the sine graph, one cycle, it looks like this. Now the distance between the maximum and the minimum should be half of the period. So Here, the time between the maximum and the maximum occurs at 5 p.m., the minimum occurs at 5 a.m. Half the period is since a full period is 24 hours in this problem, half the period is 12 hours. So if you just add 12 hours to 5 p.m., you will get the minimum. So it makes sense when we think about our sine curve as well.